video, we are controlling this solenoid door lock wirelessly using these two RF nanos. So the RF nano is an Arduino nano with built-in wireless connectivity. Okay, it has a built-in ESP32 and 01 module. So now we're gonna be using this push button to control the solenoid door lock. So this RF nano will be our transmitter, okay, the sender, and that one the receiver, okay. So yeah, now I'm going to connect the push button, okay, here with a pull-up resistor. Okay, the push button is attached to pin D3. Okay, and the resistor is connected to 5 volt from here, and that wire is the ground. Okay, the button will be a toggle switch. Whenever I press the push button, the door lock will go will open, okay, or closed, okay, depending upon the previous state. So if it was open, okay, if I press, it will be closed. If it was closed, if I press, it will open. Okay, so that's a 12 volt solenoid door lock. Okay, so we're gonna be needing an external power supply, okay, because these guys work only with 5 volts, okay, 5 volts, not 12 volts. So now I need these 3 wires, okay, with here 3 pins, okay. That's the VCC, like that. The other one is the ground. Okay, great. Ground, and that's in is the data signal, okay. The data signal will be coming in, okay, in, and yeah, we're gonna see the outcome of this, okay. So I'm going to connect, okay, that's our receiver. So what is the VCC? So VCC is phase wire, so it needs to be attached to pin to 5 volts. The middle pin is our blue wire, ground. The other pin is, let me see, in. Yeah, so in is pin 3, okay, D3, yeah, like that. Okay, great. Now my solenoid we need to set up, okay, the solenoid door lock. So the solenoid door lock, for this one we need these 3 wires, okay. First of all, I need to connect, that's the plus, okay, of my solenoid, and that's the ground, okay, the black wire, okay, like that. Now I need, as I said before, we need a 12-volt power supply, okay. That's a 12-volt power supply. Now the ground goes to ground, okay, goes to ground, okay, and this wire, okay, this connection is to be so you can connect, okay, the plus of the solenoid to normally open or to common, okay. So it's up to you. For me, I can choose, okay, normally open, okay. I think I'm going to open it a little bit more. Okay, done. Now I connect that to normally open. Okay, it's fine. Okay. Now the wire here I connect to 12 to plus of the 12-volt power supply. So now I need to connect, okay, the wire to common, okay, not to normally closed, okay. I need to connect that in here, okay. But let me open that a little bit to have more space to, yeah, that's it. Now you close it. Okay. Nothing happens. Oh. Unfortunate. That's unfortunate. Okay, let me try it again. I think I was good. It's like that. Okay, it's like that. Yeah, it's closed. Okay, so that's fine. Good. I think we're good here. When I'll be pressing the push button, okay, the receiver, if you see, okay, that's our sender, okay, our transmitter, okay. When I'll be pressing the button, okay, if the solenoid was closed, okay, was closed like that, yeah, that's closed, okay. So if the solenoid was closed like that, okay, like that, so the pin 3, okay, the receiver is going to receive the signal, okay, and we're gonna be seeing the signal on pin D3, okay. Pin D3 is going to energize, okay, the module, okay, and if it was then the normally open will closed, okay, and when it's closed, okay, the circuit, okay, is going to be completed, okay, or complete, I don't know, okay. So the door lock will going to is going to open, okay, to open like that, okay, to open. Now if it was open, okay, when I press the button, I'm going to send the signal to the receiver, and the receiver is going to send the signal to D3, and D3 is going to energize, okay, the relay module, and the relay module, okay, and the pin, okay, the pin, I mean the informally open will open, okay. If it was closed, okay, it will open. And the secret here, okay, these two wires, okay, they will be disconnected from each other. So the secret here will be open, okay, guys. And the solenoid door lock, okay, will close, yeah, will closed, okay. It will go like that, okay, guys. So now I need the cables, okay. That's the for the sender, and the cable, we need to plug in the cable for the receiver like that, okay, guys. So great. Now I need to show you the sketches, okay, for both boards. Fine. Okay, so that's the left sketch is the transmitter, as you can see here. You need to install the RF24 library. So go to library manager and search for R420, okay, library. It's already installed for me, okay. And then we are dealing with the easy button, so you need to install the easy button library. So here, that's the byte address. So the byte address needs to be the same in the transmitter and in the receiver, okay. So yeah, that's the that's the function is pressed, button point is pressed, the function that is going to write, I think, the signal to the transmitter, to the receiver, okay, the function. And on my right side you have the these libraries, okay, and I'm going to provide the sketch in the video description. So don't forget to include the object radio with parameters 10 and 9, pin 10 and pin 9. So that's the solenoid door lock, pin 3, and here we have all these things. The door state here is here. The beginning is false, so 0. So when the door state, okay, if it was 1, when I press the button it will be 0. If it was 0, when I press the button will be 1. So that depends on the previous state of the door state, okay, the variable over here, up here. So yeah, I'm going to provide the sketches, okay, in this case in the video description. Now we are good to upload the receiver sketch. I have an issue here. The upload is taking time. I think because I need to go to processor and choose this one, okay, the processor, okay, the bootloader thing. So now I repeat the process, and it will be fine. Yeah, it's fine. Now that's the transmitter sketch. Great. Yeah, it worked. Okay, the solenoid is closed, okay, like that, closed. Now if I press the button, okay, it's open, okay. Why? Because when I pressed the button, I sent the signal, okay, wirelessly to this board, the receiver, and the receiver then sends the signal, okay, to pin, I said D3, okay, and the pin D3 energizes, okay, the relay module, okay, and then the normally open is now closed, okay, yeah, it's closed. Now if I press again, okay, closed, open. So don't forget to subscribe to my channel, okay guys. So bye bye. In today's video we are controlling this solenoid door lock wirelessly using these two RF nanos. So the RF nano is an Arduino nano with built-in wireless connectivity, okay. It has a built-in ESP32 and 01
Ok,
module.
ok. Muito obrigado.
So now
pela ajuda e
we're gonna be using this push button to control.
E eu pensei que fosses o quê? O John.
Solenoid door.
O John do.
So,
não sei se conheces o.
This RF
abençoado.
nano.
Tem o John que é KB. Mas
Transmitter,
ok, tá.
the sender,
Tá tudo bem.
and that one the receiver, okay. So yeah, now I'm going to connect the push button, okay, here with a in today's video we are controlling this solenoid door lock with Uno R for Wi-Fi through Arduino Cloud. So
we're gonna be using the Arduino cloud with Uno app for Wi-Fi to control this solenoid door lock. So let's get started. Now I need 3 wires because we are using this module, this relay module, 5 volts. Okay. I need to connect it. That's gonna be the VCC. Okay, that's the VCC, and the second pin is the ground. Okay, blue wire, ground, and in is our signal. So the signal will be coming in, okay, coming in, so that we can control the solenoid door lock, okay, through this module. Okay, now the signal, I mean, that's the we connect to 5 volts. Okay, and the middle pin, I mean, the blue pin, ground, we ground it, and the third pin is our signal. So our signal I'll be connecting to
Yeah, olha, eu acho que eu sempre enviarei dinheiro para Angola.
Yeah.
Todos os meses. Tanto no fim do mês ou então
okay. One wire. Why? Because I forgot one thing. Okay. Here you are. Okay. I forgot this guy. Okay. So we need. I'm going to explain that. Okay. So we need this wire. Okay. This wire goes to normally open output. I don't know, output if you want. So now I'm going to close it. Oh, is that okay? Like that. Yeah. Okay. So normally open. Okay. So it's up to you. So you can connect the wire to common or to normally open. I think that's not really. So I'm going to connect to put that on this side of the breadboard. Okay. And now the positive side of the solenoid door lock goes to normally closed. Okay, like so. Okay, guys. Now, okay. Now I need to connect. Okay, that's a 12 volt solenoid door lock. Okay, so we need a 12 volt external power supply. Okay, that's the 12 volt. Okay, here with the 12 volt. Okay, that's the minus and that's the plus. Okay, now I'm going to connect the plus here, and the negative side of the solenoid, I connect it to or with the ground, okay, of the 12 volt, okay, like that. Okay, so that's a normally open, and that's the common, okay, common. So when the signal, when I'm going, so yeah, because I'm going to control, okay, the solenoid door lock from my phone, okay. When I'm going to switch on, the data is going to come, okay, it's going to come, okay, one, okay, bit set to high, and it will trigger the module, okay, and the normally open will now become normally will close, okay, will close, okay, and when it's closed, so it will be in contact with that command, okay, and the solenoid will go like that, okay, like that. Okay, guys, I think we're done here. Now I need to upload to show you, okay, how to create a thing on the Arduino IoT cloud. Now my cable, where's my cable? My cable. What is my okay, I need a type C cable, okay, to do that, okay guys. Okay, I need a type C cable. Now I connect. So we're gonna set up, okay, our project, okay, like that. It's yeah, it's work, like that. Okay, we're just fine. Okay, now we need to go to Arduino IoT Cloud to set up our project. Okay, guys. Okay, now we type Arduino IoT Cloud. Please create an account. Okay, guys. I already have one, so we click on Arduino IoT Cloud. Then we go to things, and we create a thing. So create thing. We click on that. Okay. Now the first thing to do is to rename that thing. Okay. So for me, IoT solenoid dot. Okay, guys. Now click on rename. Okay, now I choose to add a variable first. Okay, so door state, okay, is the name of my variable, is the variable that is going to control the solenoid door lock. So door state, and the select variable type for me is boolean. and we click on add variable. After that, I go to associated device. So I set up a new device, Arduino, because it we are dealing with the Uno R4 Wi-Fi. So connect, and you can rename your device. For me, it's Uno R4 Wi-Fi, the same name. Okay, now you cap the secret key. Okay, and you click on that. So now you unplug your board and then plug in again. Okay, just to avoid problems. So then you click on confirm. Okay, click on that and then done. Now the network here, you are going to provide your Wi-Fi name and your Wi-Fi password. So that's not my Wi-Fi password, so I need to go back to an old project so that I can copy the exact password. Okay, I think I just need to click on Windows V. Okay, Windows V. Okay, together, and I search for my password. Okay, that's it. Okay, password of my Wi-Fi. Now I put here in that thing the secret key, and then click save and update password. So I'm going to update my password. Okay, now I go to dashboards, so I can set up my dashboard. Okay guys, so I click on create dashboard, and I'm going to rename my dashboard. Okay, it's going to be solenoid door lock. Yeah, and then click on rename it. Now click on add, so that we can add the a widget. Okay, in our case is the switch. Then link the variable, the widget, to your variable door state. Okay, here click on link variable, then click done. Now we can change the position of our widget on our phone. Okay, here is for our mobile phone. Okay, I'm changing, okay, the position in the, yeah, you know. Then I go to things. I click on things, click on that. Okay, click, and then I go to sketch, because we need to change our sketch to perform this operation. So I define a variable door, okay, connected to pin 13. Now the variable door is an output, okay, because it's going to send the signal. It's going you know, out, yeah, output. Now that's the door state. Okay, it's already there. Now here we add our code here to act upon door state change. So if the door state equals 1, guess what we need to do? We need to set the pin 13 high. Okay, high. Here you can type 1 or high, the word high. It's the same. Now else, okay, if the door state equals 0, okay, is else. So I need to the door state, the pin 13 to yeah, I set the pin 13 to 0. Now I click on, that's our device detected in our port con 3. Now I click to upload. They say that I need to update, so I don't know why they are asking that, but we just follow the rules. So continue, improve your device connectivity. So we wait, and then click on continue. No, confirm. One more thing, just confirm please, and done. Okay, now we are uploading the sketch. Start verify. Okay, this is where I speed the video. Okay, wait.
Now if we click on, you see, IoT remote app from Arduino IoT Cloud, okay, we can see here our project solar node door lock. Now it's off, okay, the switch. If I click, okay, it will go on. So the door is open. If I do that, okay, the door is closed. Open. No, I mean that's open and that's closed. Okay. Yeah. Closed. Open. Okay. Yeah. And we can see that's not fake because you can see here that built-in LED is following. Okay. Yeah, because thank you so much, and don't forget to subscribe to my channel. Bye. Welcome back. We are measuring temperature and humidity wirelessly with ESP32 protocol. I'll be using two boards, two Xiao ESP32C3 boards. One of them will be the transmitter and the other receiver. And the sensor that I'm going to be using is the DHT22 sensor. Of course, we're going to be printing out the temperature and the humidity values on an LCD I2C, I2C. So guys, as I said in the previous video, the transmitter board, the Xiao ESP32C3 transmitter, needs to know the media access control address of the receiver. So to know the address of the receiver board is very simple. You just need to upload any code to it, and you're gonna see its MAC address on the output when it comes to Arduino ID. The sensor, the DHT22 sensor is part of the transmitter, and the LCD I2C is part of the receiver. So the output, the data pin of the sensor, is attached to GPIO 2, and it's VCC to 3.3 volts,
minus pin to ground. That's the transmitter. On the receiver, SCL pin from our LCD display is attached to GPIO 7, and the data pin, the SDA pin to GPIO 6. Okay, now let's go to Arduino IDE so I can show you the sketches. So the sketch for transmitter board and for receiver board.
Okay, let me explain a little bit of this code. Okay, so you need to download the DHT library, and here our pin, our sensor is attached to GPIO2, and that's the type of the sensor. We created here a object. That's the MAC address of the receiver. So here we define two variables, humidity and temperature. So guys, that's the transmitter code. So we're gonna be we will read the temperature and sensor, and the value will be stored in these variables. So here you begin the sensor DHT, and so scroll down. What else? Okay, now here you create a variable of data packed type. Then here you read the temperature and the humidity, and then you store the values in the temperature and humidity variables respectively. So then so here we are. So now you can transmit the bits, okay, the data to the receiver with help of the function ESP32. Okay guys, if the delivery is good, we're gonna print out the delivery success. Now that's the receiver code. You need to download the liquid crystal I2C library, and you do these things. So the structure example to receiver data must match the sender structure. Okay guys, so the project can work, and so you create here a variable packed of data packed type. So that's the receiver code. Here we are receiving the code, the temperature and humidity values wirelessly. So these values are coming from the DHT sensor. And we set up the lines for the LCD display. Here we initiate, okay, in the void setup function. I initiate the LCD, then I turn on the backlight. Then once the ESP now is successfully initiate, we will register for blah 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 blah. Okay, so guys, as you can see on the output, that's the MAC address of the receiver.
Okay, now testing time.
So as you can see, guys, it's working. Okay, the humidity is 77.50 and temperature 17.80. Okay, guys, so we are measuring the temperature and the humidity wirelessly. If I take out the sensor, okay, no value. Okay, if I put it back, we're gonna continue reading. Wow, that's awesome, guys. So yeah, it's working pretty well. So now we need to wait for the sensor to stabilize if you want, because we've taken it out, so it will be stable after a few seconds. It's okay. We wait few seconds so that we can get accurate values. Okay, I think it's very good. Yeah, I think that's okay. Okay, I think that's great. Thank you so much, guys.
Welcome back. We are measuring temperature and humidity wirelessly with ESP32 protocol. I'll be using two boards, two Xiao ESP32C3 boards. One of them will be the transmitter.
Hi there. In today's video, I'm connecting the Xiao ESP32C3 board to Arduino IoT Cloud to control a 12-volt DC fan. So, to control the speed of the 12-volt DC fan, I need to connect the enable input pin A to a digital pin of the Xiao ESP32C3. This digital pin will be D3. I also need to attach the input pin in 1, 2, 3.3 volt pin of the microcontroller Shell ESP32 C3 board. Now, our DC motor is 12 volts. That's why we need an external 12 volt power supply. The plus of the 12 volt power supply should be attached to the input pin plus 12 volt. The negative side of the external power supply needs to be attached to the ground of the DC motor driver. So the ground of our microcontroller should be attached to the ground of the DC motor driver and to the negative side of our external 12 volt power supply. So we are using the enable input pin A and the input pin 1 of the DC motor driver. So we need to connect the positive side of the 12 volt DC from to output 1 and the negative side to output 2. Okay, now let me show you how I set up our project on Arduino IoT Cloud.
Okay, what I did first is I created a thing, okay, and you click on that after creation. Okay, I created a variable. Okay, that's my variable. I'm going to open it. Okay, so that's the declaration of my variable. The type is integer, so my variable is an integer number, and it can read and write. Okay, and you can also edit your variable if you want, but I don't. Okay, so I'm going to quit. Now you need to attach, okay, your microcontroller to the Arduino IoT Cloud. I did that here. You also need to provide your Wi-Fi password and the name of your Wi-Fi and the secret key generated automatically by Arduino IoT Cloud. So this section is our where our sketch reside. Okay, as you can see, they automatically put our variable here to produce PWM signal. Okay, so they say the following variables are automatically generated and updated when changes are made to the thing. Okay, so I need you see I need to define a new variable called motor receives PWM wave. Okay, D3. So this variable will receive the PWM wave and delivers to our driver, DC motor driver L29810. Okay, that's my function. Okay, since as you can see here, since to produce PWM signal is read and write variable, on 2, this function is executed every time a new value is received from the IoT cloud. Okay, guys. So that's the analog write to produce the PWM signal through to produce PWM signal. Okay, guys. Yeah, and we're going to send the PWM signal to digital pin D3. So now I went to dashboard to create a dashboard. Okay, you click on create a dashboard, and then you click on that. You click on your dashboard to apply the changes or to make changes. Okay, you can also edit your dashboard. So I use the slider widget, okay, and the position of it on my mobile phone is like that. Okay, is this position. I linked the widget slider with my variable, okay, to produce PWM signal. Then the main value of my variable is 0. The max is 255. You can also change the orientation of your widget. Okay, it's okay. We click on done. Okay, done. And then we click on here, and we go back to things so we can upload the sketch. You click on your thing, click on that, and go to sketch. Yeah, so but I'm facing here problem. The thing is that it's not detecting my board, neither my port. So I'm going to upload the sketch from full editor. So I'm going to open full editor, because on full editor they always detect the port and the board. Okay, so now you choose your board, Xiao ESP32 and the board is con 6. Okay, and now you're good to upload the sketch. We wait, we wait, we wait, we wait, we wait, we wait, wait, we wait, we wait, we wait. We are waiting, waiting. Process it. Go, 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 go. It's taking time. Go. It's busy. Don't you see? It's busy. But we wait, we wait, we wait, we wait, we wait, we wait. Go, go, go. Run for your life. It is running for his life. I think we're done here. No, not yet. Is uploading the sketch, and it's done 100%. Okay, it's done. Oh, great, we did it. Okay, now we can go testing our project. Okay, guys. Now time to control the speed of our 12-volt DC fan using Arduino IoT Cloud or using Xiao ESP32C3 through Arduino IoT Cloud. we can also control the speed of our DC fan from Arduino IoT Cloud instead of using our mobile phone.
swear. We can pay, they can pay her, I swear we can't. We're
So then click on confirm. Okay, click on that, and then done. Now the network. Here you are going to provide your Wi-Fi name and your Wi-Fi password. So that's not my Wi-Fi password. So I need to go back to an old project so that I can copy the exact password. Okay. I think I just need to click on Windows B. Okay. Windows B. Okay. Together. And I search for my password again. That's it. Okay. Password of my Wi-Fi. Now I put here and that thing the secret key, and then click save and update password. So I'm going to update my password. Okay. Now I go to dashboards, so I can set up my dashboard. Okay, guys. So I click on create dashboard, and I'm going to rename my dashboard. Okay, it's going to be solenoid dollar. Yeah, then click on implement. Now click on add.
To make this robot with Shell ESP32C3 board using the protocol ESP now, you're going to be needing 2 boards, 2 Shell ESP32C3 boards. Get for yourself one L298N DC motor driver and 3.3 volt lithium ion battery for powering the receiver board. And you also need to power the DC motors. You need to power the L298 and DC motor driver with an external power supply. I got 2 3.7 lithium batteries. Get for yourself 4 push buttons for the board. So on the receiver side, I attached the GPIO tool to input pin in one of the DC motor driver. GPIO 3 I connected to input pin in 4 of the DC motor driver. I attached the GPIO 4 to input pin in 2 of the DC motor driver. GPIO 5 to input pin in 3 of the DC motor driver. That's on the receiver side. And then you need to power the receiver board with this lithium battery, 3.3 volts. You attach the plus to 5 volt pin and the negative to ground of the board, our receiver board. So you also need to connect the ground of the receiver board to the ground of the DC motor driver. On the transmitter side, I attached the GPIO 20 to the first push button close to the board. The GPIO 8 with a third push button. The GPIO 9 with a fourth push button. At last, the GPIO 10 to the second push button. Very important note: you need to know the transmitter board need to know the media access control address of the receiver board, so that the ESP now communication can be established. I'm using 2 DC geared motor. The left DC geared motor, its positive side is attached to output pin out 1, and its negative side to output pin out 2. The right DC geared motor, its negative side is attached to output pin out 4, and its positive side to output pin out 3. Let me show you how I created the sketches for both boards, transmitter and receiver.
You gotta install the ESP32 boards to have the ESP Now library. So these are my push buttons: down 1, GPIO 10, down 2, GPIO 9, push down 3, GPIO 8, push down 4, GPIO 20. So now I can remove those things. I don't need it. this info. So that's the media access control address of the receiver, aka MAC address. So inside of this instructor with the four states of the four push buttons, state 1, state 2, all the way down. Okay, so on data sent, okay, is the function that is going to tell us if the delivery, whether the delivery was success or not. If not so, it will print out failed. So the four push buttons are input pins, down 1 input, down 2 input, down 3 input, down 4 input. And to print out the messages, okay, we need the serial begin 115200, okay, to print out the messages. So once the ESP32 is successfully initiated, we will register for send CB blah blah blah. Okay. So we're gonna register the peer. So now here we are creating the variable push button state. The push button state is a data packet variable. Okay, and the push button state will save the states of the push buttons, and we're gonna be sending the data, the push button state, to the receiver using the function ESP32send. Okay, that's the receiver code, as you can see here. So that's the input pins of the L298 and DC motor driver. In 1 is attached to GPIO 2, in 2 to GPIO 3, 4, all the way down. Okay, and we need the states, state 1 and state 2, all the way down up to state 4. So now we are inside of the function on data receive, I don't know. So we need we create again this variable called push button state, and that's the income data. Okay, so we're gonna print out the state of each push buttons, okay, coming from the transmitter code. Okay, we're gonna print out the state of each push button. Okay, so now to have the robot moving, so we use the if statement. Okay, if statement. In 1 up to in 4, okay, are output pins on my receiver board. Okay, they are output pins. So if state 1 is 1, so in 1 gets 3.3 volts, else gets 0 volt. State 2 gets 1, so and 2 gets 1, else 0. State 3 gets 1, so then in 3 gets 1, else 0. State 4 gets 1, so in 4 gets 1, else gets 0. Okay, so guys, so now I think we can upload the sketch of the receiver code. We wait a little bit, we wait. Okay. I think it's done. Okay, now let me see. Okay, now we upload the transmitter code. Okay, great. So it is printing out delivery failed. That's not good. Let me try uploading again. Okay. Wait for the 100%. Okay, now always deliver. I think I'm going to do that. Okay, now it's fine. Okay, delivery success.
Okay, now let me do again the demo.